finally, the point of the whole exercise of putting an unmanned vehicle in the air or on the ground is typically to put a payload on target. There's in most cases this is a camera payload, though it could be a communications relay package, a radar, many other types of payloads. In this instance, however, this is a camera payload. So the command of the payload, we first select the payload. We can right click, as has been shown previously. I can open up camera control. In this instance it's pretty limited in that I can just switch modes. And I can also open up the video window in which I can see my video. And we do have an example video that we can start up in this, but I'll walk us through a few features first. So one of the first features to note is that in the video we actually have a compass rose. So you'll notice on the map, on the payload, I can actually grab this payload and I can drag it around. We'll point it up to the north, and what you'll see is when I release it, the vehicle's attitude rotates around pretty much 90 degrees, so you didn't see it change very much. But the north arrow is now pointing to the north. Likewise, if I rotate around to the south, you'll see that the arrow pretty much changes down to the south, and likewise around to, say, the west, and now the arrow is pointing off to the right, which is exactly where north would be. So this gives a little bit of geo-reference capability. Also within this you'll see that there's a keystone shape to the payload, and this is because of the angle and the angle of incidence from the payload to the ground. The footprint is actually calculated based on the terrain information, so in this case we're using DTED level 0. When we have the higher resolution DTED level 1 or 2, this can be a lot more accurate. But effectively what happens is that the field of view is constant on the camera, but obviously the farther away it is, the wider that angle has become, so the distance is larger and we end up with this keystone type of shape. Up here you can see that in the video we can actually measure distance across the video window. In this instance you'll see that we measure the top of it to be about 43 meters. So if you take a look at the distance here, compare it to our distance line down here, you'll see, yeah, a little bit shy of the full distance line, so that's probably about right. We can do the calculations to show it is right. And at the bottom, when we measure it, we find that that's about 30 meters. So again, we take a look at this. This distance here is at about a little over half. Looks about right. The point of that is, though, that whenever we then measure distances internal to the video, we've actually geo-referenced this video, so this distance is truly representative of what the distance would be on the ground. This can be used in order to give directions to troops that are on the move, and telling them, in actual fact, there is a bearing readout which is not visible on this particular instance of the video. But you can tell them the bearing and you can tell them the distance to go to a target, for instance. When I right click on the video, I actually have an ability to take a snapshot if I wish. This will then capture a still image of whatever video is in there right now. The address is where we actually set up where the video comes from. So in this instance, this could quite often be a port, whether that's a serial port or a TCP/IP port that for the streaming video that's coming in, or in this case what we will run is actually a file, a video file of actual video that was captured by an area on Scout, and gives a sense of the kind of resolution you have. At this point it would be about 150-200 feet high. You can see the stability of the camera, and at 150 to 200 feet, these are very small vehicles. They're pretty much invisible, electric motors, so you can't hear them, so they're very stealthy. If we wish to measure the distance between a couple of these things, because we've got a geo-referenced footprint and video, we could measure the distances across targets or whatever it is we need. On the map, you've seen me pull the video left or right by grabbing it and just dragging it to wherever I want it to be. However, I can do the same thing in the video itself, so I can click in the video and actually pull it to the right. And on the map you actually get a representation of where the video is going to be when I release and tell it, okay, this is where I want to go. Likewise, I can pull to the left. I can pull up, down, wherever I need it to go. So the video actually becomes a control interface, not just a status. So I can actually do my measurements in here. I can control it. I can pull. I can direct it to where I want it to go, and the video becomes a